Hello everyone, see you again. Chapter 2, video part 2. So let me share with you the slide. Um, so we continue from the previous video. So we are still at the project planning activity 1, defining a scope, understanding problem. So in order for you to plan any project, so you need to understand the problem by these factors, 5W to H: why, what, when, who, where, how, and how. Then after that, you establish a scope. So as the scope can be established based on the function and performance, function and features to be delivered. What is the input data? What is the output data? What is the presented content? What is the performance and constraint that bound the system? To understand the scope, you have to understand the customer needs. This is sometimes very difficult to understand the customer. So you need to be very creative in order to understand a customer, because when the system completed, then you present to the customer. Uh, if you don't understand customer, then maybe you are missing some information. Then your system will be trouble. So understand the business context, project boundaries, customers' motivation, understand the likely path for change. So next, for the project planning activities is identifying resources, human resources, reusable software resources, environmental resources. So you need to identify the resources in order to plan any project. So human resources, what is human resources? Human resources involve the stakeholders, team leaders, software team, and agile team. Um, so the stakeholders, senior managers, project technical managers, practitioners, customers, and users. So team leaders, what is the function of team leaders? Motivated, organizational skill, innovative. So this is the importance of team leaders. Must be motivated, must be have the motivation inside. Um, if a team leader don't have this kind of skill or this kind of features, so the project cannot be done. Must be motivation. Okay, organizational skill and innovative. Okay, creative and innovative. For the software team, must have skill, knowledge, able to write a coding, for example, able to use a software. So that is the software team. Number of team members required and location to do the project. Agile team, highly motivated team, technical decision autonomy, less planning, more developing. Small team, daily progress meeting. So next is identify resources to reusable software resources. Just now is human resources. Okay. The second one is identify reusable software resources. COTS, based on the COTS, commercial off the shelf component, full experience component, partial experience component. So new component. So this is the resources number 2. Resources number 3, environmental resources, software tools, hardware, network resources. Next is estimate costs. This is also one of the important part in the project planning, financial, to ensure that the project is not over cost. So you have to have a proper plan on the project cost. So decomposition technique, make or buy decision. So what is decomposition techniques? Lines of code estimation, function point estimation, process-based estimation, reconciling estimates. So this is all the techniques under the decomposition technique for estimate costs. Line of codes. Example, design a mechanical CAD software that can analyze 2D and 3D geometric data from an engineer. The engineer will interact and control the CAD system through a user interface. All geometric data and other supporting information will be maintained in a CAD database. Design analysis modules will be developed to display the required output on a variety of graphic devices. The software will be designed to control the interact with peripheral devices such as mouse, digitizer, laser printer, and plotter. So this is the example of decomposition technique of line of codes estimation. So there are 7 estimated costs which is under the line of code: user interface, 2D geometric, 3D geometric, database management, graphic, peripheral control, design analysis mode. So estimated line of codes estimation. So you can estimate the cost from this functionality of the project. Estimated size, S equals to S up plus 4SM plus SPESS divided by 6. So function 1, so we can estimate estimated LOC, optimistic LOC as optimistic 1,100 lines, for example. Most likely LOC SM 2,400 line, pessimistic LOC 3,100 line. So estimated LOC as 2,300 lines. Okay. So from there, we can do the estimated line of codes. So we get the user interface control, 2D geometric. So we sum all together of the 7 function, then we got 2,000 estimated LOC. So this is the calculation of the estimated effort. Estimated project cost 33,200 multiplied by RM4 per line. So estimated effort divided by 2,500 for the software. So you have 53 ringgit per minute. So this is the detail of the cost up to the minute payment. So this is the example of a calculation line of code. Consider the same case, function points FP estimation. So this is another way to calculate the cost, which is FP function points estimation. So draw block diagram first. User, password, run simulation, stop simulation, CAD software, user interface, message, simulation status, training data, simulation settings. So this is all the block diagram or design of the process to develop a software, okay, by a user. Configuration data, library files. So this is called function point estimation. Then we note that all the function, we name it as a external input, external output, external inquiries, external interface, internal logic files. So this is the way how to calculate it. Okay, we are using the same formula as SOPT plus 4 SM plus SPASS divided by 6. And this is the information, external input, external output. Okay, so this is the OPT. This is M. This is PSS. So estimation count 24 multiplied by average factor. Okay, and then we got the count total. Okay, so estimated count multiplied by weight, then we got the value of the cost of the project. So next, cost estimation technique 1, decomposition technique factor. If if the factor is increased, then we have this value 4 until the estimation value. So we have the adjustment value adjustment factor E. So by using the same formula, then we can calculate the estimation cost. Next is a process-based estimation. Okay, linear, iterative, evolutionary, parallel, which is suitable with customer need, team strength, environment, product type. So this is the cost estimation based on the process base. Okay, so this is another example of the process-based estimation of the process flow, task, planning, the modeling. Then we write down all the function and then percentage of effort. Then we come up with the all the figure, and then we can estimate the cost. Okay. So average estimate 53 per minute, 51 ringgit per minute, 56 per minute, 53 per minute, which is less than 4%, between 4% and 6%. So this is a good estimation. Then final estimation, we can estimate that the cost is 53 ringgit per minute, reconciling estimate. What if the variation is too high? Variation is greater than 50%. Why this could happen? So we will look at that. Why the cost of variation is too high. Okay, I stop here as a video for the chapter number 2, chapter 2 part 1. Thank you. See you again.